Okay, so this is activity 2.1, identifying graphical behaviors. If you happen to miss the last activity or lesson, all of these cards that it's talking about, the different ways the graphs are grouped, that's for this getting started. So make sure you have done this before you start doing activity 2.1 because it's not going to make as much sense. So Matthew grouped these graphs together. Why do you think he put these graphs in the same group? So if you look at these, and again, everyone could have grouped them together in different ways, but this is how Matthew, and I don't have a student Matthew, it's just this example that they're using, put these graphs together. So if you notice on this, one way that you could look at it is all of these are points. So notice point, 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 and so on and so forth. So what this is actually called, and I mentioned it in the last set of notes, is the word continuous. So this one's not continuous, but we're going to talk about it. So in your notebook, if you've happened to get your graph paper spiral if you wanted one, or your supplies, your notebook, your binder, whatever is your preference. I am not picky, so whatever you want to do, you can. So I'm going to do, I skipped a page, so I have one page in front just because I'm OCD and I like to write on that page. And then, so the very next page I put topic 1, vocabulary. So I'm going to put continuous as our first one. So continuous is what we looked at the last time. Continuous is an unbroken curve or line and it's drawn without lifting the pencil. Sorry, that should say the pencil or your pencil. So if we look at these graphs back over in the last activity that we did, you can see how those are, it's a solid line. I could draw that without lifting my pencil. Now I would have to turn my pencil, but I would do it like that. This one, notice this was talking about throwing a baton in the air. So it's called continuous. The graph is continuous. It's a continuous line or a continuous curve. If we were talking about cleaning a fish aquarium. So in this, you can see that these ones are all dots. So for continuous, I want to write an example. So our example could be amount of water left in an aquarium. So if I draw a graph, and this is just going to be a quick sketch, this would be time, and this would be amount of water. So if I'm drawing this, it would be continuous line. Because if you look like right here, if this was 1 and 2, I could tell you how much water is in the pool at 1.5 minutes or whatever. Okay, the next one is discrete. So discrete is when single data points are graphed. An example, sorry, can't spell, would be number of students in a class. Okay, so if I draw a graph here, I'll just put like days of school I guess, day of school. And then number of students in class. So you can't have 1.5 students. So these ones you will see could be like this. And then maybe I lost a few students that day. So if you look on the before school started, I had a certain number of students in my class on my roster. After one day, I lost one student. The next day, I gained a student, and then I stayed the same, lost a student, gained a student, and then lost 2 students. So you can see that the numbers are single data points, and you cannot have a half. You can't have half of a student. You can't connect this line here because it's not like it went from, say this is 12 down to 11. It couldn't have gone 12, 11.5, and then 11. So that's why it's all single points. Okay, so all of these graphs are called discrete. All of those graphs are discrete, meaning single points. Okay, all right, I'm going to turn the page and we're going to look at Ashley. So it says Ashley. I grouped these graphs together because they all have a vertical axis of symmetry. If I draw a vertical line through the middle of the graph, the image is the same on both sides. So then it says down here, show why Ashley's reasoning is correct. So we're going to draw that vertical axis of symmetry after we define it in our notebook. So, and I write really big. You don't have to write as big as me. It's what I've always done. So axis of symmetry, and this one is vertical. So this is a line that cuts an image in half vertically. So I'll do both sides. So if you look at the very first one, it makes that V shape. So the axis of symmetry so this is the vertical axis of symmetry. Notice this line, if you were to fold the paper, it's the same. It's a mirror image on both sides. Okay, so let's go ahead and what it's wanting for the show is for you to draw the axis of symmetry on each one of them. So notice you could fold that in half. And you can use a ruler. I just have had lots of practice drawing straight lines. So those are the axis of symmetry. Okay. All right, now let's look at Dwayne. I'm pretty sure that's how you say that name. So I grouped these graphs together because each graph goes through only 2 quadrants. So let's go ahead and the word quadrants. Remember, your quadrants look like the X and Y axis. This is quadrant 1, all positives if you're talking about the X and Y values. This is 2, 3, and 4. Okay, so it is saying that all of these ones only go through 2 quadrants. So 1 and 2, 1 and 2, 1, 2, 1, 2. So he thinks that they all go through just 2 quadrants. But it says, why is he not correct? So one of these actually goes through more than 2 quadrants. Notice the arrows on that one keep going up, so that would still be in quadrant 1 and 2, still quadrant 1 and 2. But look at this one. Notice his line. Notice that arrow stopped right there, but it would actually continue down into quadrant 4. So we could say graph M goes into quadrant 4. Okay, so look at your graphs and see if there are any more that go through 2 quadrants. I forgot to say that on question 2. Okay, so see if there are any others. All right, now these ones are grouped together, and he didn't provide any rationale, so let's see if we can figure out, and rationale just means reasoning. So why would these 3 be grouped together? And he's not wrong, or she, sorry, Judy, she's not wrong. Well, maybe she, I don't know. But what do you think could be a reason? So we've done vertical axis of symmetry. We've said all 2 quadrants. Well, this one goes through 4 quadrants. This one goes through 2. This one goes through 2. So that doesn't help us for grouping them together. So let's try vertical axis of symmetry. Well, that one would work, but there's nowhere you could draw it this way. So let's try a different axis of symmetry. What if I did, instead of vertical, if I did horizontal? Okay, well that works. Let's try this one. So if I folded that, would it be a mirror image? Yes, it would. So they all have a vertical, oh, not vertical, sorry, horizontal axis of symmetry. Okay, and then it says, what rationale could Judy have provided? So it's pretty much the same thing, that they are not, or that the horizontal axis has a horizontal axis of symmetry. So again, with this assignment, after all of these cards, you are going to see an assignment that looks a lot like this, and of course, I'm gonna have it set as multiple choice, but so like A, you're gonna identify which of these are correct. Okay, so that is the activity, what was it? 2.1, I believe. Yes, so activity 2.1.